High-speed bottle capping is performed by rotary capping machinery. The fundamental principles of a rotary capping machine are basically the same regardless of the equipment manufacturer. There are multiple heads on a capping turret, and on a basic mechanical capper, the heads are gear-driven around a central sun gear inside the turret. The size of a capping machine and the number of heads will depend on the speed of the production line and the specifications of the equipment the capper mates to. A large capping machine can have over 40 heads and will run at speeds in excess of 1,200 bottles per minute. At production speeds, the capping process is little more than a blur. The capper shown here is a small unit with only 9 heads. It is running between 300 and 450 bottles per minute. High-speed sorting equipment is used to orient the bottle caps before they are fed to the capping machine. A sorter will feed caps into a chute with all the caps in the same orientation, ready to be picked up by the capper and applied to bottles. In order to clearly show how the capping process operates, we are using a small capping machine running at very low speed. Caps from the sorter travel through a cap chute which feeds them single file into the capping machine. At the end of the cap chute, the caps are fed into a star wheel when needed by the capping machine. The star wheel spaces the caps out and positions them under the capping chuck which is attached to the capping headset. A guide on the outside of the star wheel keeps the caps in the pocket of the star until the capping chuck takes control of the bottle cap. The bottle caps and capping chucks come together at the point of tangency between the capping turret and the cap feed star wheel. At this point, the capping chuck descends onto the bottle cap just enough to control the cap and pull it free of the star wheel and cap guide. Once the capping chuck and bottle cap are completely clear of the star wheel and cap guide, the capping chuck descends onto the cap, fully seating it in the capping chuck. The bottle cap is now ready to be applied to a bottle. Synchronized with the caps feeding into the capping chucks, filled bottles are also entering the capper. The exact configuration of the bottle infeed will vary. This freestanding capper uses a feed screw to space the bottles out so they match the pitch of the capping heads in the capper. A star wheel captures the bottles and feeds them into the capping turret. Once the bottles are in the capper, it is important that they do not rotate while the cap is being applied. In the capper, the bottles are supported on anti-rotation knives. These knife plates have a pocket which matches the diameter of the bottle finish and multiple knife edges or spikes around the pocket which will dig into the underside of the support ledge on the plastic bottle. If you look closely, you may see that the bottles are lifted slightly as they enter the capper and then lower onto the anti-rotation knife once properly positioned in the pocket. As soon as the bottle is secure in the capping turret, the capping chuck and bottle cap descend onto the bottle and begin applying. A spring in the capping headset provides some downward force to keep the cap engaged in the chuck and to press the anti-rotation knives into the ledge on the bottle finish. As the bottle approaches the exit of the capping machine, the chuck lifts off the bottle so the bottle can exit the capper, and the chuck heads back to the cap feed star to pick up another cap. Quality checks on bottle caps include removal torque and application angle to ensure ease of removal and seal integrity. Again, in a true production environment, each of these steps happens in a small fraction of a second, and the total time from when a bottle enters the capper to when it exits with the cap applied can be around a half second.